Hello everyone, let's start. We have this equation 8 over x plus 27 over y equals to 1, right? And what we have to do, we have to find its number of positive integral solutions. Number of positive integral solutions. This we have to find. So let me explain the question, what we actually have to do. If we put here x equals to 4, what we will get? X over 4 plus 27 over y equals to 1, or 27 over y equals to, here you can cancel out, we can write it 2, and 1 minus 2 is minus 1, so it implies y equals to minus 27. So we can say that this 4 comma minus 27 is a solution of this equation. Is a solution of this equation, and moreover it is an integral solution also. Why? Because both the values of x and y are integers, right? So it is the integral solution of this equation. What we have to do, we have to find number of positive integral solutions of this equation. Okay, so let us see how we can do it. Before going to the solution, we should know about some concepts which will be used in the solution of this question. So what are they? Suppose we have a number 100 and we have to find the number of factors of 100. First we have to write 100 in prime factorized form. Then we have to deal with these exponents which are written on these prime numbers. We have to add 1 in these and then multiply them. Means 2 plus 1 times 2 plus 1, this is equals to 9. We can see that 100 has 9 positive factors. 1, 2, 4, 5, 10, 20, 25, 50 and 100. You can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the natural number factors of 100, and if we are talking about all the factors, then you can include minus 1, minus 2, minus 4, etc. also in the solution. Let's take one more example. Suppose we have to find number of factors of 525. So we can write it like 3 times 5 square times 7. So here exponents of prime number are 1, 2 and 1. So number of factors equal to, if it is 1, so 1 plus 1, here it is 2 in the exponent, so 2 plus 1, and here again it is 1, so 1 plus 1 means 4 times 3 means 12. So 12 positive factors and similarly 12 negative factors. In total 24 factors of 525 are there. So we will use this concept in the solution. So first of all, what we will do, we will rewrite this equation. We will write 8 over x equals to 1 minus 27 over y, or y minus 27 over y. Hence we can write 8 over x equals to we can write it as x over 8 equals to y over y minus 27, which is equal to y minus 27 plus 27 over y minus 27, and this is equals to 1 plus 27 over y minus 27, right? And finally we get x equals to 8 plus 8 times 27 over y minus 27, right? Now if we need the integral solutions, then this x must be an integer. Here 8 is an integer, and if we can somehow get this fraction as an integer also, then we will get the integral x as an integer. Now if this denominator can divide this numerator, if this can do so, then we will get integral factors of our equation. Means y minus 27 should be a factor of 8 times 27, right? Okay, so if we can find number of factors of 8 times 27, hence we can get those number of values of y minus 27, and for each such value we will get one corresponding value of x also, and those will give us the number of integral solutions. I'm not talking about positive integral solutions. I'm talking about only integral solutions including both negative and positive. So let us see how many number of factors 8 times 27 possess. Okay, so we can write 8 times 27 equals to 2 cube times 2 cube times 2 cubes times 3 cube. Here it is 3, so number of factors equal to 3 plus 1 times 3 plus 1. Let me write 8 times 27 equal to 2 cube times 3 cube, right? And if we want to include both positive and negative, then we can multiply a 2, so it will include positive and negative both. So how many we get? 32. So 32 factors including positive integers as well as negative integers, right? But you can see if we put y minus 27 equals to 20 minus 27 here, notice that if we put y minus 27 equals to minus 27, which is also a factor of this 27 times 8, then also we will get a solution. What solution we will get? We will get y equals to 0, and on putting y equals to 0 we will get x equals to 0. You can see that 0 comma 0 is satisfying this equation also, right? But this is not satisfying this initial equation, means 0 comma 0 is not a solution, right? But when we are finding this 32, when we were calculating this and we approached this value 32, we have counted 0 comma 0 also as a solution. Why? Because at that time we were finding the solution of this equation, not this initial one, and that's why we have to exclude this 0 comma 0. So finally we have 31 integral solutions. 31 integral solutions. So these we were talking about integral solutions, not positive integral solutions. Now let us see how we will approach positive integral solutions. Okay, for this we have to see a little bit how the graphs of the equation are made. Suppose we want to make the graph of xy equals to constant. So graph of xy equals to constant looks something like this. Here this is the x-axis, this is the y-axis. You can see that the center of the center of this graph is at 0 comma 0. Here this x-axis is the horizontal asymptote and this y-axis is this vertical asymptote, may touch somewhere at infinity. Okay, let us see another graph. This time let us see the graph of x minus 1 times x minus 2 equals to constant. What will happen? The center of the graph will shift at 1 comma 2, somewhere here. This time this vertical asymptote and this horizontal asymptote will pass through this center 1 comma 2, and graph will look something like this. Okay, nice. So how we do? First of all, we find center. We put this x minus 1 equal to 0 and we get x equal to 1, and we put this here. I wanted to write y minus 2, so we put y minus 2 equals to 0, we get y equals to 2. So 1 comma 2 is the center. Let us see one more graph of x plus 1 and y minus 2 equals to constant. So in this graph center will be shifted. Where will be the center? Let's find the center first. So x plus 1 equals to 0 means x equals to minus 1, and y minus 2 equals to 0 means y equals to 2. So minus 1 comma 2 means somewhere here is the center. This is the vertical asymptote, this is the horizontal asymptote, and graph is something like this. And moreover, we are taking this constant as positive. That's why the shape is like this. This is in the first quadrant. Otherwise, here you can see that the graph is in the first and third quadrant. If this is negative, then the graph must lie in the second and fourth quadrant. Okay, so we will use this to find the positive integral solutions. Let us see how. We reached the equation x equals to 8 plus 27 times 8 over y minus 27, right? And we can write it as x minus 8 times y minus 27 equals to 27 times 8. If we draw the graph, what we will get? Let us see. Here, center, if you find the center, we get x minus 8 equals to 0, that is x equals to 8, and similarly y equals to 27, means somewhere in this first quadrant here, right? You can see that 0, 0 is satisfying the curve, so curve will pass somewhere from here origin and then like this, right? Very nice. We were removing this 0, 0 also. You also remember this. Now here this part contains negative values of x, and this part over here contains negative values of y, and this part lies completely in the first quadrant, and that is why this is where we will get the solutions. Means if we are choosing this the values of x which are greater than 8, you know, this center is 8 comma 27, so on this side values of x are greater than 8, right? So if we are taking the values which are greater than 8, then we will get positive integral solutions. Or you can see that the solutions which are lying on this part are equal to the solutions which are lying on this part if we are including this 0, 0 also. Means we were getting 32 total solutions including positive and negative and 0, 0, right? 32 we have. So if we do the half of this, then we will get the solutions which are completely lying in the first quadrant. Means we have 16 positive integral solutions. And this is the final answer. Now let us look at the variant of this question. One more variant of the problem. What's that? Suppose we have equation 8 over x minus 27 over y equals to 1. What will happen? Let us see. Here we will get 8 over x equal to 1 plus 27 over y. We can write it as y plus 27 over y. We can rewrite it as x over 8 equals to y over y plus 27, and plus 27 minus 27, we can write it 1 minus 27 over y plus 27, and we get finally x equals to 8 minus 27 times 8 over y plus 27, and we are getting it in the form of x minus 8 times y plus 27 equals to minus 27 times 8, right? Nice. Now what will happen? How can we solve this question? This time the graph which we will obtain will look something like this. Here center is 8 comma minus 27, so here somewhere here we will get the center. And since here it is a negative sign, so the graph will be something like this, somewhere like this, right? Okay, let's draw this neatly like this. Okay, now you can see that if we are taking here, then we are getting negative values. Here also we are getting negative values. The only positive values we are getting which are here. Hence, if we take y as positive, means in this question, if we are choosing y as positive, then we will definitely get x as a positive, right? Okay, so you just try and do it yourself and tell us in comments. Okay, let me give one more hint. We can write x minus 8 equals to 27 over 8 upon y plus 27 over here, and we need to put this y plus 27 this y as positive, right? So try this by yourself and tell us in comments, and don't forget to like and share our video, and for more such videos subscribe to our channel Brain Exploders. Thanks for watching.